This video explains about diodes, its internal composition, and how it works in a circuit. A diode is an electronic check valve for current. That is, it allows current flow in one direction but blocks it in the other direction. It usually has a marking at one of its ends. This end is the cathode of the diode and the unmarked end is the anode of the diode. When the cathode is connected to the negative terminal of a power supply with its anode connected to a positive terminal, the diode acts like a closed switch and allows current to pass through it. When the polarity is altered, the diode acts like an open switch and blocks the current flow. This unique property is due to the semiconductors which make up a diode. The most common semiconductor is silicon. Let us consider a silicon atom which has 4 valence electrons in its outermost orbit. These valence electrons bind with the neighbouring silicon atoms through covalent bonding to form the crystalline structure of the silicon. At the present state, there are no free electrons in silicon to conduct electricity, so it behaves like an insulator. But when an external energy in the form of voltage is applied to the material, some electrons break from the covalent bond and become free electrons. These electrons are free to move through the crystal and can conduct electricity. Now, silicon behaves like a conductor. This transition from insulator to a conductor makes silicon a semiconductor. But pure silicon is not enough conductive to be used in a diode. So a process called doping is done to make it more conductive. Doping is done by replacing some silicon atoms with atoms of another element to make it more conductive. Consider a phosphorus atom with 5 valence electrons replacing a silicon atom. During this process, 4 of its valence electrons binds with the neighbouring silicon atoms to complete the structure. But an extra free electron is available in the atom. This free electron moves throughout the crystal and can conduct electricity. As the electrons are the mobile charges, this type of doping is called N-type doping. There is another type of doping called P-type doping, in which a boron atom with 3 valence electrons replaces a silicon atom. This boron atom requires an extra electron to bind itself to the neighbouring atoms. This vacant position, which is an absence of electron, is called a hole and is given a positive charge. Due to its positive polarity, it attracts electrons from the neighbouring silicon atoms and creates a new hole at another location. This displacement of holes is characterized as the hole moment. As the holes are the mobile charges in this case, this is called P-type doping. In a diode, one part of its semiconductor is doped as P-type and another as N-type, and they are called P region and N region of a diode. At the junction between these two regions, the holes from the P side and the electrons from the N side are attracted to each other and try to cross the junction. After a certain amount of charges have crossed the junction, these charges create a new region called a depletion region between the P and N region. This depletion region blocks any further passage of charges through it. When we connect the P region to a positive potential and N region to a negative potential, the electrons and holes in these regions are repelled towards the center of the diode, but the depletion region blocks them from moving further. The electrons and holes in the depletion region are attached to each other with a certain amount of force. So when a voltage higher than 0.7 volts is applied across it, they are broken apart and allow the charges to flow through them. Now the charges can move from one terminal of the diode to another terminal. So conduction takes place. This is called forward biasing of a diode. When the P region is connected to a negative potential and N region to a positive potential, the holes and electrons in each region are attracted towards the terminal voltage and accumulate near the terminals. This attraction causes the depletion region to become white. As there are no charges at the middle region of the diode, current cannot pass through the diode. This condition is called reverse biasing of a diode. So this is how a diode works. Hope you learned from the video. Subscribe and turn on notifications to see my future uploads.